All right, this is Precalculus, Chapter 5, Lesson 6, Homework Questions, number 3. All right, guys, this is great practice. All right, everybody look on the board. Tell me what to do, somebody. What do I want to do?
Change the base of 9.
I want to have a common base of 3.
Yes.
All right, so this is going to be 3 to the x plus 1. This is going to be 3. 9 is 3 squared raised to the 5x. Power raised to a power, we multiply. So this is 3x plus 1 equals 3 to the
10x.
What do I do now?
Now you drop the 3.
That's correct. Set the exponents equal to one another. And you can solve. I'm not going to solve it. All right, you got it? Everybody have this. All right. All right, let's go to number 9.
Stop.
Okay, right here. Ladies and gentlemen, shh. What do I do?
Take the natural log.
You can do that, or
You can change the base.
Yeah, can you do
log what?
log with the base of 3 and then 5 x?
Correct. That's exactly what I would do. And that's in math. Like way down.
Oh. Oh my gosh.
13, we're going to work a different way. You ready? You ready for 13? Because this you can put in your calculator. All right, 13 is going to be different.
For this one, are you going to do the natural log?
Yes.
Why would we not do natural log the other one?
Because we have x's in both exponents. Here, before, we don't have an x in the exponent over here. So I'm going to have exponents in my base. I'm going to have exponents. Yeah, you can't do it here. All right, so everybody look. We're going to take the ln. You can take the ln of both sides. Okay? When it's raised to a power, we multiply. So we're going to move this to the front. All right, now what are we going to do? Distribute. Distribute. Good job. All right, so this is the ln of 3 minus 2x ln of 3 equals x ln of 5 plus 5 ln of 5. All right, now what are we going to do? Move every term with a variable in it to the left. I think I want to move to the right. Make this one positive. All right, so I'm going to add 2x ln of 3 on both sides. And I'm going to subtract 5 ln of 5 on both sides. Got it? So that I'm at x ln of 5 plus 2x ln of 3 equals ln of 3 minus 5 ln of 5. What's the next step? Factor out the x on the right-hand side. Now what am I going to do?
divide,
By
both
everything
sides
but
by
X.
ln.
Divide by everything but x on the right hand, on both sides. All right. What about next?
Turn it into.
You can
Simplify.
What'd you say, Michael?
Put it in your gut.
Put it in your calculator, the left-hand side. Yeah, yes, you can. You can put the left-hand side in your calculator. Okay, let's see if y'all get it right. What number is this? 13. Do that. What does x equal? Make sure you can do this in your calculator. Sarah, you following? Does this make sense? X equals. What do you have? Negative
Negative
1 point.
1.01.
I got 1.8.
Eight.
Negative 1.2.
1.825.
3 minus 5.5.
Okay, could I know if that answer is right? How can I know? What? Plug it into the original equation, guys, and see if it's right. Okay? You can know this. Okay, this is right. I'm looking at the answer key. You got it? Order of operations matters. So do the numerator first, hit equals, then divided by, open parentheses, and do the denominator. Yeah. You have to put the denominator in parentheses. So just do them separate. Just do the numerator and denominator separate. All right, number 15. This is good review. Number 15. Okay, guys, I'm not going to work this one. We'll just start it. I just need to throw some of these away. It's the exact same type of a problem. Number 15. 2 to the 1 minus 3x equals 3 to the x plus 1. What am I going to do?
pull and multiply.
ln. I'm taking the ln of both sides. Are you with me? Okay, I'm taking the ln of both sides. Now what do I do? Move the exponents down. All right, what do I do next? Distribute the ln's to both of those. Okay, we're not going to go any further. But tell me what you would do. Move your x's to one side. So yes, I would move this one this direction, that one over there. Factor out the x. Divide by what's not x. That's algebra 2. That's algebra. All right, got it? That's 15. All right, let's look at 19. What would you do first?
Divide by 6.
I divide by 6. So So you have e to the negative 1.4x equals 21/6. Now what would you do?
Would you take the ln? Because then
you can multiply by the exponent. Or not.
I would convert this to a logarithm. The base is e. So you do the ln. What's my argument?
e, so that's 1.
No, here's my argument.
3.5.
21/6 equals negative 1.4x.
Divided by negative 1.4.
So do the ln of 21 divided by 6,
3.5 is on 25.
and then divide by negative 1.4. Y'all do this math. Negative 1.4. This is 19. I'll check your answers.
Negative 0.894.
Negative 0, right. X equals negative 0.895. Did you get it? You got it? All right, are you following this? All right, these all feel harder than what's on the test. Wait, really? Yes.
How many problems are on this test?
I forgot. I have 2 classes that have a test. It's 2 pages, front and back. It's about 20. Okay. Number 39. So this is the top of page 387. Okay, we're solving these equations. Remember, there's 2 types of equations with logarithms. What are they?
Oh,
2 types. What are they, Hannah?
it's gone.
It's gone. What are they?
Is this about where the x is?
2 types of logarithmic equations. One is all logs. Logs on the right-hand side, logs on the left-hand side. What do you do, Therese?
Well, you get it. Well, now you confuse me.
What do you do?
Give the common base.
Single log equals a single log. Then once you have a single log equals a single log, you set the arguments equal to each other. Got it? The other type of equation is when you have a constant. That's a number. You want your number on one side of the equal sign, everything else on the other side. You want a single log using the rules of logs, the laws of logs. A single log equals the number. Then we're going to exponents. All right, so let's start at 39. What type is this? All logs. All logs. I need to move that back to the exponent place. Got it?
And it only equals 6 because the argument can be negative.
Correct. Okay, look. Now you drop the ln's. You set the arguments equal to each other. Your argument here cannot be negative. So x can only equal positive 6. It cannot equal negative 6 because your argument cannot be a negative value. I cannot raise anything to a power and it equal a negative number, ever. All right, that's 39. Got it?
Yeah.
All right, 45. This is 45. Okay, what type is this, guys?
With the constant.
Has a constant. So what do we want to do?
Single log equals constant.
Single log. How do I make this a single log? Hey, Michael, you paying attention? How do I make this a single log? Left-hand side.
Distribute.
Wait just a minute. How do I make this a single log?
That's a great question. Distribute. So you distribute.
No.
Plus.
See, I tricked you with that one. So see if you're paying attention.
Shouldn't listen to Hannah.
Yep.
It's not.
Jesse, do you know? Jake?
So it just goes like x plus 9 over x.
Subtraction of the logs is division of the
See,
arguments.
I knew I was trying to throw them off. I was.
Oh, okay, good.
Don't you have log on like one side of the equation and log on the other side?
No, I have a constant.
Oh.
When you have a constant, you want a single log equals the constant. Now I'm going
Two exponents.
to exponents. What's my base? E. What's the exponent? 1 equals x plus 9 over x. Leave E as E. Leave E as E. All right, what do I do now? Multiply by x. Eliminate the denominator because it's an equal sign. So now I have e to the x equals x plus 9. We're leaving E as E. I want x equals, so what do?
Subtract.
I move every term with an x in it to one side of the equal sign.
Divide by x.
I'm subtracting the x. So it's ex minus x equals 9.
No, I mean you factor.
Now I factor out the x. What's left inside the parentheses?
E minus 1.
Now what do?
Divide by everything that is not x.
That was not
Very
precision.
Because you have to add x equals something.
X equals 9 over e minus 1. That's an exact answer. Leave it.
Yes.
You're done. E's a real number. We're going to leave E as E. That's 40. All right, yes.
On the test, do we leave E as E?
Leave E as E. Leave E as E? Yeah. All right, guys, this is hard stuff. Do you understand this stuff?
Yes.
Are you following? Yes? All right. Let's do number 47. All right. Log of x plus the log of x minus 3 equals 1. All right. Corinne, what are we doing?
Are you multiplying?
We're multiplying because it's addition. We're multiplying those arguments.
Oh, and then you're gonna do the quadratic.
All right, now what are we doing?
Well, you're distributing and then subtracting one and dropping.
I'm going to exponents. What's my base?
10. Well,
10. 10 to the first power equals
X minus 3x.
oh. Yes.
now.
You're right, Corinne.
Right, subtract the 10.
And then do the quadratic form.
Wow.
When you do the quadratic, what are we making sure? X is not a negative number.
Just fine.
All right, so y'all can do that. Let's see, that's 49. Is that 47? 47. It's only the positive. X equals 5. Actually, y'all, we know how to factor this. X minus 5, X plus 2. We didn't even need the quadratic. 5 is the only answer. Got it? All right, let's go to 49.
So brave right now.
Michael, are you following this?
Enough.
Okay, it needs to be more than enough.
I'm getting there.
Sarah, how are you doing?
I don't know.
Okay. right, somebody tell me what we can do with this.
You can. Oh, you can.
Tens?
What?
Whatever the inverse log called, but it's just 10.
Converting it to exponents. What is it, Jake?
With 10 to the log of. I'm doing the other side first, but.
No, it'd be 10 squared equals,
10 to the square root of x squared. Or something.
Wait a second.
And then you square it again.
10 squared equals our argument.
Yes.
Now what would you do?
Square the sides.
Square both sides. Hey guys,
It's a big number.
guys,
Yes.
when we square both sides, this is 1 and 4 zeros. 1, 2, 3, 4.
X squared. And then you're gonna then you can add 1 to this side. Then you can just square it. What? Wait.
Can it be a plus and a minus?
No.
Wait just a minute, just a minute.
Because the argument is squared.
Because x is squared, it can be both plus and minus. That doesn't make the argument negative. So x is both plus and minus the square root of 10,001. Your argument is not negative because that term is squared. All right, how we doing? How we doing? All right, let's do 51. Is everybody with me? Everybody with me? You with me? All right, let's do 51. All right, what do we want to do first, ladies and gentlemen? Yeah, move all my LNs to one side of the equal side. Keep my constant here. All right, so I'm going to subtract this on both sides. I'm going to subtract this on both sides. Leave it equal to 1. Make sense? Then what do we do? Single log on the left-hand side, working left to right.
Subtraction and
Division.
Subtraction is division. Actually, no, that's x squared. All right, so let's do the that one first. I don't need a parentheses. Well, I should use a big parentheses.
I was like, all right.
X squared plus 1 over x minus 1. Now we divide again, right? All right, so now this is the ln of
X squared plus 1.
x squared plus 1 over x minus 1. That's divided by
X plus
x plus 1. But let's simplify it. So we'll multiply by the reciprocal. Got it? Multiply by 1 over x plus 1. 1 over x plus 1. So that equals the ln of
X squared plus 1 over x squared minus 1.
Yes, that
equals
equals 1.
1. Right?
And actually,
Okay, now we're going exponent to ease. That's right. So I'm going to have to erase, guys. Are y'all good? I'm going to have to erase. So I'm going to erase up here.
that would be.
Okay? I'm going to start by erasing up here. So here I have e to the first power equals x squared plus 1 over x squared minus 1. right? What am I going to do now?
You, multiply by x squared minus 1. I get it.
I'm going to multiply both sides by the denominator to eliminate the denominator. So multiply by x squared minus 1, x squared minus 1. You got it so far?
And then you move.
Right, I'm gonna go ahead and distribute the e. So this is ex squared minus e equals x squared plus 1.
So you can subtract the x squared.
I'm going to move the x squared left. I'm going to move the e right. Right? I'm going to isolate every term with an x on one side of the equal sign, and everything else is going to the other side.
You can.
So I'm going to add e. I'm going to subtract x squared. Got it? Does that make sense? Everybody following? Just a minute. Let me write this. So now we have ex squared minus x squared equals, that eliminates, e plus 1.
So you can
Yeah.
take out an x squared.
Factor out an x squared. Yes, ma'am,
I was
Therese?
just wondering how you know whether or not to leave e as e, because I was like solving for a lot of these.
Always.
Oh,
Leave easy.
that's fine.
It's sort of like leaving pi as pi.
I don't know if I realized six and stuff.
Yeah. All right, factor out the x squared. Then
Divide by what you.
I'm gonna have to erase this. Divide by e minus 1 on both sides.
And can it be two solutions because it's squared?
You have to take the square root. Yes.
So you,
You have to take the square root.
but none of them work.
But can it be negative?
Wait.
No, because let's look back at the original one. Okay, yeah, it's gone.
Okay, but in
Here's my arguments. Look, here's my arguments. We have x squared plus 1. But guys, that doesn't matter, right? That doesn't matter if it's positive or negative. Okay, let's look at the next argument. X minus 1. Does that matter if it's negative?
Yes.
So it cannot be negative. So it's only the positive. X is the square root e plus 1 over e minus 1. Do you see how we decided whether or not it can be the positive or the negative or both?
it'll all have to be squared.
They would all have to be squared. Yes. All right, 53. Last one. Everybody with me?
Oh, yeah.
What is the formula for half-life?
0.5 raised to the k over h.
Yes, and h represents the half-life. So it's the original amount times 0.5, typically raised to time or k over the half-life, equals the amount over some period of time. All right, how old is a piece of ivory that has lost 36%? So it's lost 36%. How much is left?
64.
Left is 64%. What's the half-life of carbon?
Isn't it
5,000,
730?
5,730.
We just supposed to.
Yes, half-life of carbon is 5,730. Okay, so now what do I do?
Well, you can.
How much do we have right now?
64p.
We have left 64% of the original. That's what we have left, right? So guys, let me ask you a question. Are you listening? Should my number of years by now be greater or smaller than 5,730?
But I'm sorry, this is your new number. This is the number.
No, how old is it? From the day it died to now, how old? So should it be greater than or less than 5,000?
Less.
Less than, because it's not been half the time. It's not been 50%. So my years better be less than 5,730. Do you see that?
It's right here.
Thank you.
Right by the end of-
Got it? All right. Equals P, the 0.5 time over 5,730. Yes?
What section did we learn this problem in? I gotta be fine.
It's lesson 6. It's like example. Well, wasn't it in 5 and 6? It was in several.
Yeah, and I told you to have like the most too.
Yeah. All right, we'll look at that in a minute, okay? Divide by P on both sides, right?
Yes, right.
Thank you. So we have 0.64 equals 0.5 raised to the T over 5730. All right, what am I doing now? Logs. I'm going to logs. All right, so what am I going to write? The log. What's my base?
0.5.
0.5. What's my argument?
0.64.
0.64 equals T over 5730.
And you can multiply by 60.
Multiply by 5730.
But only after you complete the logarithm.
Correct.